So on homework number 9, I'm looking at number 1 on your homework question. This is basically a multiple choice. It says to estimate the value of P, the population proportion of successes, use the point estimate X. Well, let me give you an idea what that means. P is your population proportion. For example, let's just say that there's exactly 100 people in the classroom, no more, exactly 100, and 40 of them believe that we should recycle. That means our P would be equal to 40 out of 100, which is 40% or equal to 0.4. Now, if I were to take a sample, let's just say 20 of those students out of 100, okay? 20 students. And then 4 of them said that, yes, they believe in recycling. That would mean it's 4 out of 20, okay, which is 20%. Now that 4 out of 20 happens to be not the population proportion, but a sample proportion, right? It's a sample. So that would be signified as P hat, P hat. So the P hat is kind of what represents the true population proportion. So therefore, in this question number 1, when it says to estimate the value of P, which stands for the entire population proportion of successes. Successes in our case would be like those who believe in recycling. That would be called your X. And you don't use the point X to figure that out. The point estimate is actually called P hat. Therefore, the answer is false. Part D is the correct answer. It is because to estimate the value of P, use the point estimate, which also can be called as P hat, which is X divided by N. In our example, out of 20 students, I said 4 of them believe in recycling. That means X is 4 and N is 20, which comes out to be 4 out of 20, right? Which actually is 20% in this case. So that's number 1 for you. Number 2, which of the following groups has terms that can be used interchangeably with the others? So basically they're asking us which terms kind of mean the same. So sometimes we call it percentage, sometimes we want probability, sometimes we want proportion. So think the 3 P's, percentage, probability, and proportion. So those are the things we need to know for this particular answer, for this particular number, rather, number 2. On number 3, why is it necessary to check that n multiplied by p hat and n multiplied by q hat, both of them has to be greater than or equal to 5? Now, you see what happens is, this is a requirement. If you do the reading or if you watch the video, you would know that it is necessary to check that n times p hat and n times q hat, both of them are greater than or equal to that number 5, because if either of the values are less than 5, the distribution may not be normally distributed. And this is what the premise of this whole assignment is. It's something to do with 1 proportion Z interval. That's what we're going to look at. The letter Z, right, deals with normal distribution. So to make that happen, to make it work with Z distribution, we want to make sure the requirement is that n times p hat and n times q hat is both greater than or equal to 5, then only you can find the critical value of Z. That's another way of saying what is the when we did the normal CDF earlier, normal CDF, for example, let's say the left is negative 999999999. The right side is 1.25. And then the mean is 0 and the standard deviation is 1. That would give you the probability. But if you did the inverse normal, that would give you the Z-score, right? That is the critical value in this case. And you will see some examples soon. Number 4, express the confidence interval. So they give you 2 numbers and they want you to put in a form of p hat minus E less than P hat plus E. So what they're saying is this P that you see in the middle, the true population proportion, right? It's saying it's between 0.035 and 0.129. To put it in percentage, that's 3.5% and 1.29%. That's the true population proportion is. So that's your confidence interval. That's how confident you are. Okay. So in other words, you can also rewrite that as what you see as an answer. P hat, or not P hat, P rather, true population proportion is between the two numbers 0.035 and 0.129. It's just another way of writing it. You can write it the way they want us to write, or you can write it also in the parentheses. If you had taken algebra course, algebra 2, you would have seen that we can write that down as an interval notation. So this is your interval notation right here. And this is more like a set builder sort of, right? P is between these two numbers. So that's number 4 for you. Number 5, now they give us the other way around, right? They give us P, true population proportion, is between 0.111 and 0.999. That's like 11.1% and 99.9%. And they want us to write it down in the form of P hat plus and minus E. So how do we do that? Okay, so there's a formula that you kind of need to know, okay? So the formula is this. So I'm going to try to share this with you. Let's see if I can get another share here. And let's see if I can move this a little bit. Okay, so now I can see my own work. All right, so what you need to know is how do I find P hat? So P hat is, right, the upper end, right, plus the lower end. I don't know, I call it U and L, and then divide by 2. That's how you find the P hat. So in our case, the upper end was 0.999, and the lower end was 0.111, and then you divide that by 2, and when you do that, it comes out to be 0.555. So that's how you find the P hat. Okay, that's the formula for P hat. Now you need to find E. So that's called margin of error. P hat is the sample proportion, E is the margin of error. So how do I get the margin of error? Well, it's U. Instead of plus, it's minus. So minus L divided by 2. So upper end was 0.999. Lower end, so it's minus 0.111, and then divide by 2. And that comes out to be total of 0.444. Okay, so in other words, when you write this down as an answer, you could write like this: 0.555 is the sample proportion, and it's a plus or minus some error. You've probably seen that on newspapers, plus or minus 3% sample error and so on. So in our case, it's 0.444. So that's the idea of how to write this down in this case. Okay, so on number 6, it says use the sample data and confidence level given below to complete parts A through D. Okay, a research institute poll asked respondents if they felt vulnerable to identify theft. In the poll, okay, out of 932, N is 932, X, 575 said yes. So that's what we know, okay? In the poll of 932, 575 said yes. Now, remember, this is not the entire population. It's a sample. So out of sample of 932, 575 said yes, they felt vulnerable with identity theft. So now you want to know 99% confidence level. So you can never be 100% confident unless you actually went and collected all the data of the entire population, right? We're trying to infer from what we know from the sample to predict about the entire population. So 99% you want to be confident with that. So let's see what happens now. So what we need to do is first it says find the best point estimate of the population proportion P. All right, so I'm going to go step by step, but actually the best way to do it is going backwards. But let's go forward anyway. Number 8, find the best point estimate of the population proportion P. That's P hat. So what is P hat? P hat is X divided by N. So X is 575 N is 932. So 575 divided by 932, voila, the answer comes out to be 0.617. That's part A. Part B, identify the value of the margin of error E. Now, there is a formula for margin of error of E, okay? Margin of error of E, there's a formula. And you could see that if you go into the question help, but I'm gonna try to bypass that soon. So I'm gonna show you, here's an example. You may not be able to see this on the screen, but I'll tell you what happens here. The formula, as I could keep on going, there's the formula. It's a little messy looking formula. E is equal to the critical value of Z times the square root of P hat times Q hat divided by N. That's how you get the margin of error, okay? So you could do that. So in our case, what is the critical value? I'll tell you about that soon. P hat happens to be 0.617 from part A. Q hat is just the opposite. So it's 1 minus that number, 0.617. And then N happens to be 900 and what was it, 32, right? So what is this Z of critical value? Well, remember it said 99% confident. So if you do inverse normal of 0.995, comma 0, comma 1, it's going to give you 1.96. But I think this number is very valuable for you to remember. 99% confident, you should remember Z score is 1.96. Now, why 0.995? All right, so I'm going to explain to you why 0.995. It happens, okay? So if you look at a 99% confidence on a normal curve, what you're looking at is this way. This part is 0.99, right? 99%. And you want to know what this value is. That's the critical value for the Z. And it came out to be 1.96. I think they said 99% confidence, is it? Yes, 99% confidence level. So that's what they're looking at. So what they want to know for 99%, so 1.96, this is the 0.99, this is now there's 1%, so there's half a percent. So if you look at this, this is 0.05, oh sorry, 0.005, and over here is also 0.005. So what is the area to my left? 0.995. If I add 0.99 and 0.005, right? If I do that, then the whole thing comes, oh, sorry, it's not 1.96 in our case. That was an example that they gave for a different one. So what is the number for us? So this number is not correct. It's going to come out to be 2.546. So that's what the number is going to come out to be. That's what the number is going to come out to be, 2.546 right now. So let's see what I can tell you. Let's go back to why they got 1.96. Let's see if I can do that for you. So let's take a look of what I just did earlier, whiteboard. So let me explain this, okay? So you got 0.99, right? 99%, 0.005, oh, not 2.546, 2.576. So 2.576, okay? That is the number that it comes out to be on your calculator. Now, let's see what they did with the example that they have. So let's go back here and let's take a look. All right, so let me explain why it was 1.96 earlier. So if you see, I don't know if you're able to see this on the screen, hopefully you are. So look at this. This question says 95% confidence, right? Stockman 95% confidence. So that means the middle of the bell curve is 95%. So you're gonna have 5% to the left and right total. So you're gonna have 2.5% on the left, 2.5% on the right. So really, that means 97.5% all the way to the left. So what is gonna be your Z score? So if you go through the long route, you'll see that if you put in the formula, notice they come up with, 95%, they come up with 1.96 there. So that's for 95% confidence, okay? So that's the idea. Majority of the time we use 90% confidence, 95% confidence, and 99% confidence. 95% confidence, Z score is 1.96, okay, critical value. 99% confidence, the critical value is 2.576. And if it's 90%, it's 1.645. And you can find all of that answer using the inverse normal button. But I'm going to try to show you a little easier way of doing this problem. So it says construct the confidence interval, all right? So plus or minus all that stuff. But you can really use a calculator to find all this answer. So what you have to do is on your calculator, you need to find something called one prop z interval. So one prop z interval means, where do I find it? Well, you go to stat button, and then you go to tests, okay? There's edit, there's calculate, there's tests. Go to test button, and you keep scrolling down, not the test, you're not doing the test, but you're doing the interval. So as you keep on going down, after 7, 8, 9, 0, there's a letter A. If you look at letter A, it says one prop Z int. Stands for one proportion Z interval. That's what you wanna hit enter. And now when you hit enter, it asks for what is X, what is N, what is C level, and then it says calculate. So I'm gonna put the numbers down. X in our example is 575. So X is 575. N in our example is 932. So 932. And the confidence level, C happens to be 99%. So 0.99, calculate, and then it gives me the answer of 0.57594, comma 0.65797, which 3 decimal places is 0.576 right here and 0.658 right there, right? So you can actually do this answer right away. Part C, actually find the confidence interval. And once you find this, then you can find what is P hat. Remember the formula I gave you earlier, upper plus the lower divided by 2 gives you this number. And how do you find the margin of error? Upper minus the lower divided by 2. So you don't have to worry about finding that critical value and doing the long route. This is much faster and much easier, okay? And then part D says, write a statement that correctly interprets the confidence interval. Choose the correct answer. Okay, you have to say, how confident are you? So in this case, you are 99% confident. So the answer, one has 99% confidence that the interval from the lower bound to the upper bound. This is my lower bound, 0.576. This is my upper bound, 0.656 or 658. From the lower to the upper bound actually does contain the true value of the population proportion. So what you're trying to say is, in reality, if you were to do the true population proportion, you are saying you are 99% confident that the true population proportion value falls between these two numbers, which is 57.6% and 65.8%. So if you're going back to the question, remember you did a 932 sample. So people who are vulnerable to identity theft, you can pretty much guarantee 99% confidence that the true population proportion, the true percentage that people believe they are vulnerable is between 57.6% and 65.8%, and you are 99% sure of that. So that's the idea, okay? Number 7 is the same thing, see? Just go right to the proportion. Okay, one proportion Z interval. What is X? X is, where is it? 943. Let's see. In a study of cell phone use and brain hemispheric dominance, an internet survey was emailed to 2669 subjects randomly selected from an online group involved with ears. 943 surveys were returned. Construct a 90% confidence interval for the proportion of return surveys. So 943 is X, N is 2669, and C is 0.90. Once you do that, the answer is going to come out to be these two numbers right here, 0.338 and 0.369. How do I find P hat? Again, upper plus the lower divided by 2. How do I find margin of error? Upper minus the lower divided by 2. Number 8, straight right to the find the proportion, 99%, right? So C is 0.99 this time. X, what is it? 328 is girls out of 410 babies born. So X is 328, N is 410, and C is 0.99. And when you do one prop Z int, one proportion Z interval, your answer is going to come out to be 0.749, 0.851. Okay, and does the method appear to be effective? Yes, the proportion of girls is significantly different from 0.5, meaning 50%, right? 75% roughly, 74.9%, and 85.1% believe that this method is effective, that the clinical trial testing a method to design to increase the probability of conceiving a girl. If it was 50%, if that was between, then it could be nah, either girl or boy, equal. But this is saying you have a 74.9% to 85.1% chance of having a girl rather than 50% chance. That's why it is significantly different. Number 9, okay, constructing a 95% confidence. Well, there it is. N is 429 green peas, X is 153 yellow peas. So what does it say? A genetic experiment with peas resulting in one sample of offspring that consists of 420 green peas and 153 yellow peas. Part A, construct a 95% confidence interval to estimate of the percentage of yellow peas. Okay, so it's 153 is your X, and you got to make sure you add all the peas together, right? So it's 153 plus 429. So what does that come out to be? 582, the total. The total peas is the both of these together added. So X is 153, N is 582, C happens to be 0.95, and you get this answer. It was expected that 25% of the offspring peas would be yellow. Given that the percentage of offspring yellow peas is not 25%, do the results contradict expectations? So what did the answer come out to be? 22.7% and 29.9%, right? Isn't 25% in between here somewhere? So the answer is, given that the percentage of offspring yellow peas is not 25%, because the answer is not 25%, if you were to do that, 153 divided by 582, do the results contradict expectations? And the answer is no, because isn't 25% right here in between? It is. So no, the confidence interval includes 0.25, right? 0.25 is between these two numbers. So the true percentage could easily equal 25%. So that's the idea. Number 10, refer to the data set of 20, okay, so 20 randomly selected presidents given below. Treat the data as a sample and find the proportion of presidents who are taller than their opponents. Use that result to construct a 95% confidence interval estimate of the population percentage. All right, so if you were to go to the data, you will see, you know, out of all the presidents, find the ones that was taller, height versus the opponent, right? So once you get that, you got the X and you got the N. N is just 20. So 20 total. And then you have 95%, so C is 0.95. It's going to give you this answer. Okay, is this 50% inside here? It is in here. So you can't tell that the taller person had an advantage or the shorter person had an advantage because 50% is here. If this answer was 53.2 to 66.8, then you would say, yeah, the taller person had a little bit more advantage, okay? So if greater height was an advantage, then taller candidates should have won more than 50% of the elections. But in this case, the greater height does not appear to be an advantage for presidential candidates because the confidence interval, see, it does include 50% is in here. That's why. Now, number 11 is totally a different question, right? It asks you, what is the minimum sample size needed? So let's read the question. A researcher wishes to estimate with 95% confidence the population proportion of adults who think Congress is doing a good or excellent job. Her estimate must be accurate within 5% of true proportion. A, no preliminary estimate is available. Find the minimum sample size needed. And for B, find the minimum sample size needed using a prior study that found that 20% of the respondents said they think Congress is doing a good or excellent job. Okay, so let me show you through the question help. So when you go to the question help, it says view an example. There's a formula that you need to know. And the formula is this. If you have, the formula is right here. The sample size required to obtain, right? The formula is N is equal to P hat multiplied by Q hat, parentheses, the critical value divided by margin of error, the whole thing squared. Now, if you happen to know your P hat and Q hat, you put those numbers there. If you don't know what the P hat or Q hat is, then you put 0.5 for P hat and 0.5 for Q hat, okay? Our example, part A, says we have no prior information, right? So that means P hat's gonna be 0.5, Q hat's gonna be 0.5. And if you, for part B, it says 20% of the respondents said they think Congress is doing a good job. So P hat is 20%, which is 0.20. So Q hat is gonna be 80%, right? 0.80. So P hat is 0.20, Q hat is 0.80. That's the only difference between part A and part B. So what is the critical value? What is the percentage that you want? Did you say 95% confidence? It talks about 95%, and that is 1.96. Remember that number, 1.96? So if you look at this example that I'm looking at right now, it talks about 99%. For 99%, your critical value is 1.96. So you're gonna see that. As you go continue, you're gonna see the crap, 99%. 99% is 2.576. 95% is 1.96. Some numbers, it's hard to remember all the time. So 99% Z-score, the critical value is 2.576. So they give that example, right? So your critical value would be 2.576. E is your margin of error. Do you want the error to be what? Within 3%, within 2%, within 5%? If you want within 6% here, then the bottom part is going to be 0.06. So let's see if they have done it somewhere. Look at this formula right here. See? For part A, you don't have any prior study. So P hat is 0.5. Q hat is 0.5. Critical value is 2.576 for 99% confidence level. And you want margin of error to be 6%. So that's why it's 0.06, and you square it. When you square it, the answer is going to come out to be 460 point whatever. You always round it up, not off, round it up. So the answer is 461. So you need 461 people to survey if you have no prior information. But let's say you have a prior information. So in part B, in this example, if you look at for part B, this time the P hat they give us, the P hat happens to be actually 0.47. So Q hat is going to be 1 minus P hat, which is 0.53. So you have 0.47 multiplied by 0.53 multiplied by 2.576 divided by E. What is the margin of error? 6%. So 0.06 squared. And when you do that, the answer comes out to be 460 when you round it up, okay? So it was not a big difference in this case, 460 versus 461. So getting the prior help did not really help us that much, because basically you just needed one less survey, that's it. So in our example here, when you're looking at this, so what we're gonna do for part A? Part A, P hat is 0.5, Q hat is 0.5. My critical value, this one is 95, so 1.96 divided by, you want within 5%, so 0.05. And then you square it, and you're gonna get n equal to 385, okay? So let's see if I can show you what I just did. See if I can clear this. Let me clear this. Okay, so for this one example, right, you want n. So n equals, right? We don't know what P hat is, a 0.5. We don't know what Q hat is, so that's also 0.5. Okay, you multiply, then you square root of. Critical value at 99% confidence level happens to be 1.96, or 95% in this case, happens to be 1.96. E is 5%, so that's 0.05, right? You get that, and whatever that is, you just go ahead and square this number. Okay, and when you do that, this whole thing comes out to be 384 point something something, but you always round it up, so the answer is 385. That's part A. For part B, you know that the prior study tells you that there were 20% responded that favored in this case. So for part B, the P hat is going to be 0.2. And the Q hat is going to be 0.8, right? They're equal to 1. And then exactly the same thing down here. And that whole thing comes out to be 245 point something something, which is really 246. So you can see you don't have to do as many people survey. You only have to do 246 compared to 385 if you had prior knowledge of this. So that is the idea, okay? All right, so let's go to number 12. Same question, so I'm going to pass that one. Number 13, same question, so I'm going to pass that one. Same question, number 14. That's kind of nice when it's the same, right? So, one of the numbers that you should really remember, 90% happens to be 1.645. 95% happens to be 1.96. 99% happens to be 2.576. Okay, those are the numbers that we use a lot of times. Okay, multiple choice. For the same sample statistics, which level of confidence would produce the widest confidence interval? Okay, you want to be very confident. So you really want to give a lot of room, so you're not going to be in error. You're not going to have an error. So you say, 99% confidence, because the level of confidence, as it increases, so does the critical value increase. Let me give you an example. Let's say that I have no idea whether people really believe in recycle, right? I don't know. Could be 10% of people believe in recycling. Could be maybe 40%, right? I'm not so sure. So if I said, I am 99% confident that the people who really believe in recycling is between 40 and 60%, how do I know I'm 99% confident? It could be only 38%, and I'm wrong. So I could say, you know what? I'm 99% confident that between 1% and 100% of the people believe in recycling. Okay, right? I think I'm pretty good about that, 99% sure of that. So the margin is a lot wider. So that's what they're saying for number 15. Okay, multiple choice is the same. So I'm gonna go to skip that one. Number 17, 18. Oh, same question again somehow. I gave it to you again. I don't know what I was thinking. Okay, number 20. Which of the following is not a requirement for constructing a confidence interval for estimating the population proportion, right? We just been doing it. Okay, the sample is a simple random sample. Yeah, you gotta make sure that it's a random sample. You can't be biased. It cannot be biased sample. There are fixed number of trials. Yeah, you want like 580 survey or something like that. And the trial are done without replacement. Okay, so what is it? Which of the following is not a requirement for constructing a confidence interval for estimating the population? The trials are done without replacement. It's not, okay, it's not a requirement. So yeah, you can do replacement. It's all right, as long as it's a fixed number. The probability does not change, in other words. Probability stays the same. And then that's it. So the answer is part C. Let's see. We have number 21 right now. So on number 21, now we're going to change a little bit, okay? We were doing for population proportion, right? Percentage of people who believe that we talk about recycle and so on. But now we're not interested in percentage. We are interested in actually averages, right? You can find a sample mean to infer something about the population mean. For example, the average, let's say, exam score, okay, in a college. Let's just say that everybody took the same exam, the entire population. Now we know what the average is, that's population mean. Let's say the average was 73. So that means mu, right? The population mean is 73. But because of money, because of time, we're not going to be able to find all the exam scores of everybody, perhaps. So we might need to take a sample. So let's just say we take a sample of 500 college students instead of 10,000, and then give them an exam and then found an average of that exam. Now, whatever exam average you got, that's not mu any longer, that's X bar, the sample mean. Can we use that to say something about the population mean? Can we predict, okay, the population mean, if the entire college population had taken the exam, this is what their average would be. You're never going to be 100% correct. So you could be like 95% confident. So now everything shifts. Same idea, but instead of population proportion, we're looking at population mean. So let's look at number 21. Refer to the accompanying data display that results from a sample of airport data speeds in megabytes per second. Okay, so look on the right side here. They already gave you that, but this time you don't see any Z score. You see something about T interval. So all along we have been doing Z scores. Now we're gonna go to T scores. You know, they're very similar, but T score is also a bell curve. Eventually, T score, basically the bell curve, as the number gets larger and larger and larger, T eventually becomes Z score. UT is usually for a smaller number of data, a lot of times, okay? And we'll talk more about that later. But they give us look at the confidence interval. They give us the interval between 13.046 and 22.15, okay? That's not a percentage any longer. That's an average. X bar is 17.598. So if you were to take the upper plus the lower divided by 2, it would give you that. And margin of error, again, upper minus the lower divided by 2, that would give you the margin of error. Standard deviation for the sample is 16 point blah, 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 and the total number of data is 50. So express the confidence interval in the format that uses the less than symbol, like this symbol. So what is the true population mean between these two numbers? 13.046 and 22.15, that's part A. What is the best point estimate? What is the mean, the population mean actually? So what you gotta do, population mean is really the same as X bar, right? You just add these two together and divide by 2, and you're gonna come out to be 17.60, okay? And what about the margin of error? You take the 22.15, subtract 13.046 and divide by 2, and you're gonna get 4.55, and so on. In constructing the confidence interval estimate of population mean, why is it necessary to confirm that the sample data appears to form a population with a normal distribution? Okay, because the sample size of 50 is greater than 30, the distribution of sample means can be treated as a normal distribution, right? Greater than 30, once again. If it's less than 30, you see, then we should look more into the T distribution, okay? So let's see if I can give you some examples. Number 22. Now, there's one other term you're going to learn is something called degree of freedom. If there's a total of 50 samples, degree of freedom is one less than that always. So instead of 50, degree of freedom is 49. You don't need to worry too much about it. Just know that it is one less than the total number. What is the critical value? See, T now, not Z anymore, for 95%. Remember, for Z score, Z critical value for 95% was 1.96, right? For T is 2.01. That's pretty close. How do they get 2.01? Well, let me show you by the table first. Remember, it's 95%, which means the two tails have 5%, right? The two opposite tails is 5%. So if you look at area and two tails is 5%, that's 0.05. So that's the third column, okay? Degree of freedom is 49. So here's the degree of freedom. So you go all the way to the bottom, and degree of freedom, as you go 40, 45, and 50 jumps to 50. So there's no 49, but 49 is pretty darn close to 50. So you're gonna look at the third column, and that says 2.009. So that's really 2.01. So that's how they got 2.01. Or on a calculator, inverse, no longer Z, inverse T, that's what you gotta do. So inverse T on the stats button, right? On the distribution, you go there and you find the inverse T. When you do that, what is the area to my left? If the area is, what is it, 99, 95? So 95 is in the middle. That means 2.5 is on the left, 2.5 is on the right. So that means 97.5. So you gotta do inverse T of 0.975. If you do that, and then I think degree of freedom it asks, degree of freedom happens to be 49 in this case, the answer is going to come out to be 2.01. That's how you can do this. Okay, number 23. They want us to find, what is it? Construct a 99% confident interval estimate of the mean. See, this is very important, of the mean. If you notice, mean means the population mu, right? So what do I do? Okay, on a calculator, you go to T interval this time. No longer one prop Z interval. You go to T interval. Same place. Go to stats, right? You go to stats. You go to, let's see, you go to stats. and then you go to tests, and then you go to T interval, which happens to be the number 8, not number 7. 7 is Z interval. So you go to number 8, which is T interval. Now, it gives you a section input. Are we dealing with data or are we dealing with stats? Well, in this case, it gives us stats. So you want to make sure your stats is highlighted. X bar. What is X bar? Well, it looks like the average is 98.7. See, average is 98.7. So you're going to type in 98.7. So 98.7 for X bar. S, sample standard deviation, is 0.63. So you're going to type in 0.63. N, the total of how many? 106 body temperature. So 106. And then the confidence level. What is confidence level? How much? 99, so 0.99. And then you say calculate, and it gives us the answer of 98.539 and 98.861 on your calculator. There it is. You don't have to worry about all the formulas and everything. This just gives you right to the point and right to the answer. So what does it suggest about the use of 98.6 degree Fahrenheit as the mean body temperature? Is 98.6 in between here? Absolutely. This suggests that the mean body temperature could very possibly be 98.6, right? That's the idea. Number 25, okay, this time instead of giving you stats, they give you data. So make sure you put this in L1, all these numbers in L1. And now when you do T interval, instead of putting your stats, which you could do that, I guess, you could find one variable stats, L1, and write down what your X bar is, write down what your standard deviation, sample standard deviation is, do exactly like what we just did. Or you better yet, just put these numbers, all these numbers in L1. Then go to, once you put in L1, go to stats, go to tests, go to T interval, and then instead of highlighting stats, highlight data. Then under the list, L1, right? So you want to make sure the L1 is typed in. Then frequency, you want to keep it as 1. This is no longer, frequency is still 1, so just 1. And then confidence level, C level in this case is, what is it, 98? So you put down 0.98 and calculate, and when you do that, the answer comes out to be 0.271 and 1.155. Number 25. Okay, I'm gonna make sure that I take this question out of here. Well, okay, you don't need to worry about this too much, but somehow it got in there. So N is 21, S is 65.7, and the platelet counts of woman 98% confidence is there. And the degree of freedom is 20, right? So if you look at 21, do you see one less than that is 20, the degree of freedom 20. This is called chi-square on the left and chi-square on the right. So if I look at the data, you'll see, all right, so if you're looking at this, so what are we looking at? N is 21, so degree of freedom is 20. So you go under 20 right there, right? 20. What are the numbers? 8.260. So do you see 8.260 is here? And what is 37.568? 37.568 is right here. Is that it? It's a little hard for me to read, but that's it. So if you look at 0.01 here, for this one up here, and then if you look at here, it is, what is it? 0.99, right? So if you look at this, that means 0.99. If you look at 0.99 is the area. If you look at to the right this time, so 99% is to my right and 1% is to my left. So the numbers are 8.260 and 37.566. So that's all it is. We're not going to deal with it. The confidence interval estimate of this standard deviation is 47.9 and 100.2. So in this case, you would do the confidence interval for the standard deviation. So I would say, let's avoid this question. So I'll take it out soon. Number 27. Okay, we're back to doing the population proportion again. Let's see. Yep, population. So we did that already. Number 26. Number 27. Same thing. Number 28. Same thing again. Number 29. Yep. Same repetition. Number 30. Same repetition of finding the total number. Oh, but wait. If he wants to first determine the percentage of adults who have heard of the brand, how many adults must he survey in order to be 90% confident that his estimate is within 7% of crew population percentage? Okay, so yeah, we did that earlier. Number 31 is the mean body temperature, which is T interval, and 32 is again the mean, so that's T interval. So I hope that helps you. The only thing that I will change is number 25. You can pretty much disregard for right now. So accidentally I put that there. Well, initially I wanted to put it there, but then I decided that chi-squared is not something we need to really worry about right now. So omit number 25, pretend like you did not even see it. And that hopefully helps you for today's homework. Now, I will also give you another video which actually explains step by step the longer method, the longer way, right? By using the formula. Also, the formula or TI-84 can be also used, and that video is also going to be given to you. So you have a lot of resources to be able to finish this homework and the quiz. All right, good luck with this, and I will talk to you soon.